Hi, this is Tom, amateur rater call sign N8FDY, and today it's time for another meter review. This time it's the Fluke 87 Roman numeral 5. Some call it the 87V. Anyway, that's what we're reviewing today. And I'd show you what comes in the box, but I opened this box a long time ago and stuff's been out of it, so I don't use this box anymore. Here's what I keep it in now. This is what I keep it in. I got this off of Amazon because, to tell you the truth, I am not that fond of Fluke cases. And this one looked pretty good. It's not 100% hard, it gives, but it's still definitely harder than the Fluke cases. Let's see what we got in here. All right, we got the meter. And we also have, you know how Fluke gives out those nice stiff, well, I sold those. Sold them at a Hamfest just a little bit ago. I use Probe Masters. I wouldn't use a meter this good with crappy leads. Why they give out crappy leads when they make halfway decent leads once in a while, but they give out the crappy ones, and so I keep these in here. What else? Well, the Probe Masters do come with little grabbers and alligator clips, so you got whatever you need. And they did include a thermocouple. I don't have a way to accurately measure temperatures, so I can't tell you whether this is good or not, but I do use it for checking out heat on components, but you know, you don't need precision for that to tell that, you know, once it gets near 90 degrees centigrade, you know you're doing something wrong. Here's a rundown of the features of this meter. It is CSA listed in Canada and the US, which means it's been safety tested by a third party. Cat 3 1000 volts and Cat 4 600 volts. It's a 6,000 count meter. It does have a 20,000 count for a few of the ranges. We will cover that in the 20,000 count meter review group. It has a basic DC accuracy of 0.05%, plus or minus one least significant digit. Has true RMS. Has a 32 segment analog bar graph. It has min-max average function. Has a peak, min, and max. Has auto hold. Has a low pass filter for AC voltages. Has a K-type thermocouple. It has auto off override. You can disable the beeper. It comes with a smoothing mode you can activate. You can enable zoom mode for the bar graph. You can enable the meter's millivolts range to have a much higher impedance. It comes with a 9-volt battery, and it has a Fluke limited lifetime warranty. All right, let's turn it on. You do have a backlight. There's dim, and they have a second level, not as dim. So we will do some voltages with that. This is 2.5005, and the Fluke reads it at 2.500. Here is 5.0009, and the Fluke reads it as 5.001. Here is 7.5016, and since this is a 6,000 count meter, it goes over to 7.50. Now, Fluke does have an option to go 20,000 count. Well, actually 19,999. Let's see if we do that. We get 7.500. But since this is a 6,000 count meter review, we're not going to use the extra precision on this. We'll use that when we include this in the 20,000 count meter review. So let's put it back. This is 10.0015 and the Fluke reads it as 10.00. All the DC voltages I tested with this meter met the specifications for accuracy as stated in the manual. The accuracy specifications for the voltage range was the best of this group of 6,000 count meters. Well, now we'll do some AC voltage measurements. We're going to give you one example. Here, using my arbitrary waveform generator, we're going to show you 2 volts, and then I'll show you on the tables all the other measurements. We're using the Fluke 289, which is my most accurate on AC voltage that's portable, because I don't want to drag the Keithley out here. That's going to show you what's coming out of the generator, because I can't get the generator to be exactly 2 volts AC, but really close. So we're getting 2.0009 according to the 289, and the 87's reading that as 2.002. All the AC voltages I tested on this meter met the accuracy specifications as stated in the manual. The accuracy specifications in the manual for these ranges were the highest of all the 6,000 count meters I tested. Now we're going to measure some DC current. Let's put it in microamp, which it already is, and let's put this in. If you put it in the wrong place, it warns you. So since we're doing microamps, we have to put it in the little microamp socket. Now, like most Flukes, if you're using a range that has AC and DC and you have to pick one or the other, it always defaults to AC. So now we got to tell it to go to DC. This is 0.89 microamps, and it reads it as 1.0. Here's 9.21 microamps, and it reads it as 9.3. Here is 99 microamps, and it reads it as 99.2. Here's 131.8 microamps, and it reads it as 132. Now we're going to switch it to milliamps, and again it defaults to AC milliamps. We want DC, so you have to do that. Here's 1 milliamp, and it reads it as 1.02. Here is 9.98 milliamps, and it reads it as 10. Here is 99.4 milliamps, and it reads it as 99.4. All the current measurements I tested on this meter met the accuracy specifications as stated in the manual. And the accuracy specifications in the manual were the highest in this group of 6,000 count meters. This is a comparison of the accuracy specifications for all the 6,000 count meters that I tested. If you notice, the red background for the meter model number indicates that those models were not third-party safety tested. All the ones with the blue backgrounds were. You can also see that the Fluke 87 Roman numeral 5 and then the Fluke 87 Roman numeral 5 Max all have highest accuracy in this group for many of the ranges. The only ones, and this is strictly talking about the volts and current, the only ones that they're beat by is the DC millivolts is beat by the Fluke 177, and the AC microamps is beaten by the Cindy 18B Plus, which is amazing because that's a $20 meter. Someday those guys might improve all their other specs and beat everybody else. Well, now we're going to measure some resistance. We shorted the leads and we get 0.1 ohms. So we're going to take the little rel or delta symbol button, and when you push that, it'll zero it out. So it'll compensate for that 1.1 ohm offset. Now we can measure some resistors. Here's a 1.0004 resistor. And it measures it at 1.1. Here's a 10.007, and it measures it at 10.1. Here's a 100.069, and it measures it as 100.1. We have a 1.0001 kilo ohm resistor, and the meter is reading it as 0L, which usually means OL, or overload, or overrange. You go, why is that happening? Well, we're in delta mode. When you're in delta mode, it automatically forces you into manual ranging. So we're now stuck in the 600 ohm range. And to get out of that, we have to hold down the range button and go back to auto. But it won't let you do that because you're in delta mode. So you have to get out of delta mode. Then you can hold down the range button to go back to auto. So now it reads 1.000 kilo ohm. Here is 10.009K. And it reads it as 10.00K. Here's 100.02 kilo ohms, and it reads it as 100.0. Here is 9.97 mega ohms, and it reads it as 9.96. All the resistance values I tested met the specifications as stated in the manual. And for the ranges below 100 kilo ohm, this meter had the best specification in the group of 6,000 count meters. A reminder that there's a written review with a link in the description of this video that goes to my GitHub site that has the written review of this meter. All my video reviews have a corresponding written review, so more detail is in there. All right, let's go check some capacitors. Well, we have some stray capacitance going on these leads. Some meters aren't sensitive enough to pick that up, but this guy is. So we're going to use our old delta function again. Zero that out, and now let's measure some capacitors. This is a 12.38 picofarad capacitor. It measures it at a 0.01 nanofarad, which is equivalent to 10 picofarads. And considering that this capacitor is very small value, much smaller than this can resolve, that's a pretty close guess on this meter's part. Here's 102.56 picofarad, which would be equivalent to 0.102 nanofarads, and we're getting a 0.10 reading, so that's pretty close. Here's a 1.005 nanofarad, and it's reading it as 1.00. Here's a 9.921 nanofarad, and it's reading it as 9.94. Here is a 99.51 nanofarad, and you notice we get the 0L or the OL overload because, again, we're using delta mode and we're locked into the range. So we have to turn off delta mode, and then we have to switch to auto range by holding down the range button. So now we get 99.8. Here's a 1.009 microfarads, and we got 1.009, 8, 10. So it's kind of hovering around we could see if the smoothing mode will help that. So let's turn this off. So we turn it off, you hold down the range button, and it says S for smoothing mode. And then we'll go back up to capacitance. Right. Now you notice, turn on the backlight. So you notice in smoothing mode, it doesn't jump around as much. Kind of averages it more. So now it's averaging it out to 1.009. So now you know what the smoothing mode is for. Here's a 10.294, and it reads it as 11. Here's 112.2, and it reads it as 112. Here's 994.5 microfarads, and it reads it as 1001 microfarads. In my initial testing, the meter couldn't read the 10 picofarad capacitor. But when I was live doing the demo, it did. So, but it's still, that's so low of a value for that range that it really isn't a useful measurement. But for all the others, the accuracy met the accuracy specified in the manual, and the accuracy specified in the manual was the best of the group of 6,000 count meters for capacitance. Here's a chart comparing the accuracy of the resistance and capacitance values for this group of 6,000 count meters. The 87 Roman numeral 5 did pretty good in the low resistance and in all the capacitance ranges. It was the best accuracy. But the 87 Roman numeral 5 max beat it in the upper ohms ranges, and in the highest ohm range, the Bryman beat the two Flukes. So it's an interesting environment. But for the most part, the Flukes put in some impressive accuracy figures. The way you get this into continuity mode is a little different than other meters. You leave it in resistance mode, and then you press the little speaker button. We're in continuity mode, and we're going to see what happens with the ProMasters. All right, looks like it's latched. Let's see how fast we can go. Oh, pretty fast. Fast enough for me, that's for sure. Anyway, that's continuity. It's pretty loud. Well, now we're going to do some diode testing, and of course we'll start out with the LEDs. Here's the red LED. It looks pretty bright, and and you also have the forward voltage. This meter, I believe, has the second highest voltage in this group of 6,000 count meters for diode check. Here's the yellow LED. Looks pretty bright with the forward voltage. Here's the green LED. Pretty bright with the forward voltage. Here's the Schottky diode with the forward voltage. Here's the small signal diode with the forward voltage. Here is the rectifier diode with the forward voltage. When the forward voltage is within the range that this meter thinks a diode should be, it'll actually beep. So let me show you that. I got to listen quietly because it's not a very loud beep. All right, so much for the diodes. To change the battery, you have to remove the boot And then there's a battery door that has two little latches that are captive, and you turn those counterclockwise and take the cover off, and there's your 9-volt battery. Unfortunately, to change the fuses, you must totally disassemble the unit. So you have screws, self-tapping screws that go into plastic that you have to remove and carefully put back when you're done. And here's a close-up of where the 440 milliamp and the 11 amp fuses go. Well, let's go over the pros and cons of this meter. Well, let's go over the good parts of this meter. It was third-party safety tested by CSA. It met all the accuracy specifications for all the tests. It had the highest or above average accuracy specifications for most of the ranges. It had the highest diode test voltage, and it has the Fluke's limited lifetime warranty. Well, now the not so good parts of this meter. It had a really strange anomaly where the accuracy specifications for the 600 kiloohm, 6 mega ohm ranges weren't very good. I mean, they're average, which is pretty good for most of these meters, but for this meter, it shouldn't have been average. It should have been up there. Its sister meter, the Max, had a better accuracy specification for these ranges, so it's kind of weird. The other thing is you have to disassemble the meter to change the fuses. I mean, that's annoying. I know it does have the warning, so you should probably not have to change the fuses if you pay attention to the warning, but it would be nice if they had an easier way to change the fuses. Well, in conclusion, I like this meter. It is big and bulky compared to some of the other meters, and I admit this meter's not for everybody, but as long as Lowe's has it on sale for $319, I can't see why you wouldn't want to get one of these if you want to have the highest accuracy in a 6,000 count meter. And in volts, amps, and resistance, it will kind of do 19,000 count if you put it in the, but we'll explore that when we review the 20,000 count meters in that series. But for a 6,000 count meter, it has all the options you need, and I know it is expensive, and for many people, the two Brymans we looked at, the Greenlee 510A and the EEV blog meter are probably more in the price range of $150 that many people be comfortable with, and for many people they're fine meters. But if you want to move the accuracy level up a bit for especially voltages and capacitance, this does a pretty good job. I don't know, it definitely wouldn't take the place of a 50,000 count meter, but you really don't use a 50,000 count meter every day. This meter I keep in my ham shack where I have the radios. It's also the family room, but I keep that there all the time. So I got this meter at hand. It's the first meter I go to if I'm going to check something out. So anyway, this works for me. It might work for you, or maybe the less expensive ones will work for you too. But I have no reservations recommending this meter if you can get it at Lowe's for that $319. I checked last night and it was still there, and they still had them in stock. The original sale, it cost more, a little bit more, but and they went out of stock, so I figured that was it. But no, a couple of weeks later they were back in stock and they lowered the price. So I don't know what's going on with that. So if you really think you want one of these, and if Lowe's still has them on sale, then definitely get them. But no, I wouldn't pay $500 for this. No way. But and some places charge that much for this. But anyway, hope that helps. I know there are some people who really are anti-Fluke because they say, oh, why spend all that money for you don't get much? Well, I think having the better accuracy and having the warranty so you can tell Fluke, hey, this meter doesn't work in the accuracy you specify. But very seldom does that happen. They seem to be pretty reliable, and I haven't heard too many people complain. So, but it may not be your cup of tea, and that's perfectly fine. Like I said, if for some people that's a side 18B for $20 will be enough for them. You know, I don't recommend a meter that hasn't been third-party tested for safety, but you know, some people, all they need is that $20 meter. But for me, this is the meter I like. But you may have a different opinion, and that's why I'm trying to include lower-cost alternate options. And we have one more meter to go in the 6,000 count meter review, and then we'll take a break because I got to do some antenna work, and then we will come back and start our 10 to 20,000 count meter review and go through that. And once we're done with that, we'll take another little break, and then we'll do our 50,000 and greater count meter reviews. So stay tuned, as they used to say in the old days when it was television. So this is Tom, N8FDY, saying 73 and take it easy.